Today in this lecture we will study about public key distribution. Why we go for a study of this topic, that is public key distribution? Because we have seen that we can use public keys in order to distribute the secret key in the secret key cryptographic system. And the problem is that the public keys are public to the users or to everyone, and we are not sure the authenticity of these keys. So first we know that we can use public keys are used for distribution of secret keys, but we are not sure whether these public keys which we are using are they authentic or they are not authentic. Okay, and therefore the distribution of these public keys, when we go for the distribution of these public keys, we are not sure whether we are distributing a authentic key or not, so it's going to be an issue. So for the distribution of these public keys is an issue, and for that we have different categories, we have different techniques which are there to distribute this public key of a user. So the first technique that can be used for the distribution of a public key is the public announcement. So this is the first technique that can be used for the distribution of the public key. The second technique that can be used for the distribution of public key is publicly available directory. Third technique is public key authority, and the fourth technique can be used for the public key distribution is public key certificate. So in today's lecture we have to study all these different techniques that can be used for the public key distribution in detail. First technique is public announcement. When we have to distribute the public key of a user, this is the first technique that we can use. And here the key is sent to other participant, or it is broadcasted to other participants or community at large scale. And this can be done by appending the public key to the message sent in the public forums. Okay, we send the message to the public forums because we have to broadcast the message so that it should reach to everybody, and when it reaches to everybody, that message is appended with the public key, and that message is appended with the public key of the user, and it is sent to the public forums from where everybody can see those forums, and the keys are available to everybody in that case. Okay, and what are the public forums? So the public forums can be your news groups where you can share these messages and which are appended with the public key of the users. And news groups can be the public forums, usenet, and your internet mailing list. So these are the public forums where you share the message or you broadcast your message, and your message is appended with the public key of the user. So that is kind of public approach. So you see, this approach is quite convenient, but it suffers from major weaknesses. What are the weaknesses? Anybody can forge these keys. Okay, or anybody can forge these public announcement, because these are available to everybody, these are available on the public forums. So anybody can forge these public announcement, they can modify it, and they can read all the encrypted messages that are meant for the intended users. Okay, because they can forge the public keys also. So that is the biggest weakness, or you can say the limitation of this particular approach of public announcement. So I don't think that it is a preferred way of sharing the public key. So the keys can also be forged for the authentication, and when the keys are forged, and then these keys can be used by the attacker, or they can use the different keys for the broadcasting of the messages. Okay, so there is limitation of this particular approach. Then you have next approach, that is a publicly available directory. So in this approach, what happens, a trusted third party is involved, and that trusted third party maintains a dynamic directory, and that directory will have a tuple which is going to have two entities. One is the name of the participant, and in front of that you will have the public key of that participant. Okay, so there is going to be an entry for each participant, and this directory is maintained by the third party. So in this directory, what you are going to have, in the directory you will have a tuple like this. You will have name of the participant, and in front of the name you are going to have public key of the participant. Okay, and so on. This is the name one of first participant, and so on. You will have number of participants and number of public keys, their respective public keys. Okay, so this is going to be a directory, and this directory is dynamic, and it is maintained by a trusted third party. Okay, so each participant has to register register with the directory authority by sending its public key. Okay, so each participant has to register with the directory authority, and the participant has to send its public key. So in this scenario, what you are going to have, you have a trusted third party which is maintaining a directory. So there will be some directory like this, and this directory will have number of entries. Okay, and each user is going to send or share its public key with this directory. So here for example you have user A and user B. So user A will send its public key to this authority, and similarly user B will send its public key to this third party, trusted third party which is maintaining the dynamic directory. Okay, and in this scenario there should be some electronic connection between each user and the directory. So there has to be some electronic access by each user of this directory, and whenever the user wants to access its public key, user should be able to do that. And also if user desires to replace the key or wants to change the key in this directory, then there should be that provision available. Okay, and when you see that this kind of approach is more secure as compared to the previous one. The previous approach is public announcement. When we compare this approach, it is more secure as compared to the previous technique, which is public announcement, but it suffers from a limitation also. And what is that limitation? For example, uh, for example, if a person succeeds in computing the private key of the authority, so this authority is going to have its private key of authority. Okay, so if this key, that is a private key of the authority, if it is compromised, then it can tamper the with the records and can get all public keys. Okay, if the attacker gets the access to the private key of the authority, then the attacker will tamper the records, and also it will the attacker will get the all the public keys of the users which are stored in the directory, or the attacker can modify the records, the tuples in the directory also. Okay, and in future the attacker will use all those keys for impersonation. Okay, either for impersonation or for eavesdropping, for listening of the communication, or for impersonating, that is behaving on behalf of somebody else. Okay, so that is the limitation of this particular technique, which is publicly available directory. So next is your public key authority. In this approach, what we are going to use, we are going to use a central authority which will maintain a dynamic directory of the public keys, and these keys are distributed to the users after exchange of several messages between the authority and the participants. So this approach is going to be similar here. We again involving what? A trusted third party. we are involving a trusted third party. Okay, but it is different from the previous approach in a sense that here, instead of having direct electronic access to this third party, what here we do, we have to exchange a number of messages. So a number of messages will be exchanged between whom? Between the authority, the third party, and the participants. Okay, so here a central authority maintains a dynamic directory of the public keys, and these keys are distributed only after exchange of several messages. Fine. So I will draw a structure here that will represent the number of messages and the number of the number of messages that needs to be exchanged. So, for example, here you have an initiator A, and you have another entity which is as a responder. Suppose its name is B. The same scenario where Alice and Bob, they want to communicate. This is Alice and this is Bob, and in between them we are going to use a public key authority. So here we have this public key authority. So first of all, a first message will be sent by the initiator, that is Alice. So here we are going to have first message, and in this first message, what we are going to send, we are going to send request message that is concatenated with timestamp t1. Okay, so this is going to be sent from Alice to the third party. Okay, and then in response to this, there will be another message, that is message number 2, and the contents of this message are in the encrypted form, and here they are encrypted by using the private key of authority. And what we are going to encrypt, we are going to encrypt the contents. In the context, you are going to have public key of B, because A is sending the request for the public key of B, the authentic public key of the B, which is concatenated with the original message which was sent by the Alice to the third party, that is request appended with the timestamp t1. Okay, and this is the response message that we are going to get from the trusted third party. Okay, and a similar kind of request will be sent by this responder, but before that, the Alice will send a message to Bob, and this is suppose the message number 3, and it has the contents which are in the encrypted form, encrypted with the public key of Bob. And what are the contents? Contents are identifiers of Alice, and there is going to be a nonce. Nonce is used for representing the currency of this message, that is the current status of this message. Okay, and after receiving this message, Bob comes to know that Alice wants to communicate, and then Bob will send a request message as message number 4, and this is the message as request message appended with the timestamp t2. Bob will send this message to third party, and this request message is the request for attaining the public key of A, the public key of Alice. So in response, as message number 5, this trusted third party will send a message in the encrypted form, and the encryption is done by using private key of authority, and the contents are public key of A appended with the original request message, and it is appended with the timestamp t2. Okay, and this fifth message will come back to this responder B. Okay, after attaining this message, now B will send a message to A. Okay, the message number is going to be 6, and the message here is in the encrypted form. Encryption is done by using public key of A, because it can be decrypted by the private key of A. That's why, because, and this public key of A is obtained in this message, and the contents are here: two nonce, nonce 1 and nonce 2. Nonce 1 is the nonce here which was sent by the Alice, and it confirms that this is the current message. It is not a replay attack, so it is going to be received by the Alice, and in response to that, Alice will send a final message, that is the message number 7, to Bob, and this message is in the encrypted form, encrypted with the public key of Bob, and it will have nonce 2 to show that message contents are not modified. Okay, so in total there are 7 messages. In these 7 messages, two communicating parties, Alice and Bob, they acquire the key, public key of each other from the third party, trusted third party, and then they initiate the session for the communication. Okay, so in this technique, if you see that there are different parameters. One is timestamp. Timestamp is used to avoid replay attack, or to get the current version of the public key, and also authority. There is an authority which signs the message sent to the participants. So we have a trusted third party, and this trusted third party is signing the public keys sent to the users. Okay, for example, here this is signed by the private key of the authority, and what are the contents? The public key of the B. Okay, we are getting the public key of Bob, and in this message here we are getting the public key of Alice. Fine, and it is signed by the third party. So we are using the third party which signs the message sent to the participants and appends the request message with the key to assure the participants that their request was not altered before the reception by the third party. Okay, that's why they are appending the request message also. Here the initiator and the responder means Alice and Bob, they send nonces to each other to avoid replay and masquerading attack. As I said, these nonce, as nonce n1 and nonce n1 and n2, they are sent to each other just to assure that there no replay attack has been occurred. Okay, this is a bit complicated, but it is more secure as compared to the previous scheme. In the previous scheme, we had an authority and we had two parties, and we had a direct connection, electronic connection, and these two parties were able to modify or replace or exchange keys, or they can access this directory electronically. So there was a drawback, that if the private key of the authority, if it gets compromised, then the attacker can tamper or attacker can modify this directory. But here, instead of using a direct approach, here we are exchanging a number of messages, and then we are assured that we are getting the authentic keys from the third party. Okay, that's the difference, but still there is an limitation of this approach. Okay, so the limitation of this approach is that here the third party, the directory authority, is going to be the bottleneck in this system. Okay, and this third party is also vulnerable to tampering. See, this authority is also vulnerable to tampering. Okay, so that's the drawback, or that's the limitation of this approach, and that's why we go ahead, and there is another approach which is called as public key certificates. Okay, this is the fourth approach, and here a trusted third party is again used, and this trusted third party signs the public key certificates of the users. Now, what is this public key certificate? A public key certificate consists of a key and an identifier of the user or the key owner, which is signed by the third party. So in public key certificate, what we are going to have? the public key of the user, the identifiers of the user, and this public key certificate is signed by the trusted third party. Okay, and either these public certificates, they are kept in the on the public forum, and when there are signatures of trusted third party, then it is assured that it is it is the keys are authentic, or these public certificates, they are directly exchanged between the two participants. Okay, so in this approach of key distribution, the participants exchange certificates to deliver their public keys, and instead of contacting each other, they instead of contacting an authority or a third party for public keys, the participants exchange their certificates directly. Okay, so it overcomes the drawbacks of approach number 3, where we had dependency or the bottleneck of our third party or the authority that we were using for distribution of the key. But here, instead of using third party, the communication the communicating party or the parties or the participants, they are directly exchanging their certificates. And what are these certificates? These certificates containing key, the public key of the user, the identifiers of the users, and the it is having the signatures of the trusted third party. And this trusted third party can be a government agency or a financial institution that is trusted by the users. Right? So the participants exchange their certificates to deliver their public keys, and thus instead of contacting an authority for public keys, the participants exchange their certificates directly, and it overcomes the limitations of approach number 3. Fine. The structure of this kind of key distribution scheme, let me draw the structure first. You have a certificate authority here, and you have two communicating parties. For suppose you have Alice here, and you have Bob as a second communicating party. So first, what you need to do is the Alice need to share its public key with the certificate authority in order to get a certificate signed by this authority. Then, in response to this message, Alice is going to have the certificate as CA. So, Alice is going to have a certificate as CA, and the contents of this certificate are going to be signed as they are in the encrypted form. They are going to be signed by this private key of authority, and the contents are the public key of A, that is Alice, which is concatenated with the identifiers of Alice and timestamp. Okay, timestamp T1. So these are the contents in the certificate of A. Okay, similarly, B, Bob will send a message, and that will contain public key of Bob to this authority to get it signed. Okay, and in response to this message, Bob will get certificate as CB, Bob certificate, and the CB is going to have the contents like this. So I will write here CB is equal to, in the encrypted form, so encryption is done by using private key of authority, and the contents are public key of Bob concatenated with ID B, that is identifiers of Bob, concatenated with timestamp T2. So this is what Bob is going to receive as its certificate. And after that, when these two parties they want to communicate, they have to send the message. So in this kind of scenario, this is going to be the message number 1, and here the certificate of A will be sent to B. So these two messages, they are not counting in the communication. These two messages, they are not counted in the communication because they can be done individually by the participants at their own places before starting the communication. In order to get the certificate, they can have the certificates prior to the communication. Okay, and then they will just share these certificates with each other in this manner. So in this way, how they can share their public keys in this particular scheme, and there are just two messages which they exchange and they get the public keys of each other. Okay, so this is quite simple scenario, and also it overcomes the limitations of approach number 3, where we had the dependency on the trusted third party, so that is also avoided here. Okay, so to obtain a certificate, the user will present his public key to the certificate authority and gets it signed, and the user can then publish this certificate on some public forum, or they can simply exchange with each other. And for this scheme to work, some of the requirements are need to be satisfied. And what are those requirements which need to be satisfied? Any participant can read the certificate to determine the name and public key of the certificate's owner. That is the first thing. Second thing that should be satisfied is that any participant can verify that the certificate is originated from the certificate authority and is not a counterfeit. Okay, the certificate that this participant A is receiving or participant B is receiving, that it is coming from the some legitimate third party, which is agreed upon by the all the participants. Okay, and it's not a counterfeit; it's a authentic certificate. Okay, only the certificate authority can create and update the certificate. This thing should also be satisfied, because the participant should not be able to modify or create the certificate, uh, because that will create some ambiguity, so that should not be done. Any participant can verify the current status of the certificate or the currency of the certificate by checking the timestamp. That's why we are using timestamps here. And the currency of the particular certificate, whether it is a valid or it is an older version, so you can get it by checking these timestamps. The exchange of certificates is having only two messages. Okay, that is that need to be exchanged between the two communicating parties. However, each participant needs to apply for the certificate by sending its identity, timestamp, and key to the authority. That we are doing here in this first message for both these participants. And the timestamp is needed to validate the currency of the certificate. The formatting for formatting of public key certificates, we are using a standard that is X.509. This standard is used for the formatting of public key certificate, and this standard is used in most of the security applications or in networking. For example, for IP security, we use it for IP security. We use it for SSL, secure socket layer, and we use it for SET, that is secure electronic transaction, and also we use it with the SMIME protocol. Fine. These are the applications where we use this standard, that is X.509, and this standard also responsible for giving us the format of public key certificates. The certificates where we which we used for the distribution of the public key. Okay, so this is all about the public key distribution, and there are four approaches, and all the approaches are discussed here. And the first three approaches, they have some demerits, they have some limitations, but this fourth one that overcomes the limitations of the approach number 3 also. Okay, so this is all in this lecture. Thank you for watching.